Today we're going to look at something really, the good news is this is stuff you guys already know how to do. There's really nothing new today. It's just a matter of looking at things a little bit differently. So, oh, it's frozen. No wonder. Okay, so you guys know how to factor trinomials. We did that a ton last unit. Well, let's have everybody put phones like completely away so they're just out of the picture. Don't let those distract you. You got to really focus on this. So what if I ask you to factor this trinomial? No big deal. What's the variable in that trinomial? U. Yeah, could be x, could be u. It doesn't really matter what the variable is, right? They're interchangeable. They all work the same. So what would I do? What would the magic numbers have to do here if I'm going to factor this trinomial? The magic numbers m and n, we'll call them m and n, would have to multiply to what and add to what? What would they have to multiply to, Johnny? Negative 12, exactly. Okay, Mackenzie, what do they have to add to? 1. Okay, good. They add to C and multiply to C and add to B, right? So what numbers do that? Yeah, 4 and negative 3, right? That makes sense? So we would say m equals 4, n equals negative 3, and we could factor that guy then. We know if we break this apart, those would have to be u's, wouldn't they, right? So when I distribute, I'd get a u squared, and my magic numbers would just be plus 4 and minus 3, and I'd be done, right? Okay. Well, what if we swapped out the u's? Instead of having the u's there, what if I plugged in x squareds instead, right? So I had something like, well, I tell you what, let's even do something else. I'm going to go back for a second. What if I swapped out u equals x squared, right? Then I would get something like this, wouldn't I? I would get x squared squared, where it used to be a u is now an x squared, plus what used to be this u now becomes an x squared minus 12. Well, how would that factor? You see it would factor the same way? Everybody get that? Right? It's going to factor the same way that this is just going to break up into whatever goes there, right? Whatever that is. It could be a u, it could be an x, it could be an x squared. If that's the same thing as that is. So I've got a trinomial kind of in pieces of x squared instead of in pieces of u or in pieces of x. It's still going to factor the same way, right? I still have to find the same kinds of magic numbers. They have to multiply to negative 12 and add to 1. But this time, if I break this apart and factor it, what would have to go there and there? X squared, right? Everybody see that? It's got to be an x squared. Because when I distribute, I'd have to get this thing times this thing. Well, x squared times x squared would be x squared squared. Anytime I multiply something by itself, that's the meaning of squaring, isn't it? Right? Everybody give me thumbs on that. Does that make sense? Okay, so this would just become an x squared, and that would become an x squared. The magic numbers would be the same. They'd have to do the same thing. They'd have to still multiply to negative 12 and add to 1. That's how we do it with a trinomial, right? So we're still just going to get plus 4 and minus 3, right? Okay, so we can kind of think about this. If we started off with the polynomial, x to the fourth plus x squared minus 12, we would just ask ourselves, is there a way for us to break this into pieces that make it look like a regular old polynomial, like trinomial, right? So I can factor it. Could I do that? Well, here, yeah, I could, right? I could break this into x squared plus x squared to the 1, and it looks normal, right? Now, if I cover up those x squareds with these, I don't know, what are these, yellow eggs? It looks like a regular old trinomial, right? where I've just maybe covered up an x or something, or covered up an x or a u or a y, right? And it's going to factor, well, we know that whatever this thing is, when I factor it, it's got to go, it's got to go there and there because it's being squared, right? And the magic numbers would have to multiply to negative 12 and add to 1. Those are my coefficients, aren't they? There's a 1 there, right? So my magic numbers are 4 and negative 3. So as long as I was able to break this up into pieces that made it look like a regular quadratic trinomial, it's going to factor the same way they normally would, right? You get that? So I just have to think about this x to the fourth plus x squared minus 12 as being built like this. X squared squared plus x squared minus 12. And then it factors normally, right? So you guys already know how to do this stuff. We just had never thought about it in that context back in Unit 4, right? So help me out with this one then. Everybody take a look at that, and what do you think? What could I do there? How do I need to maybe think about this one? How do I need to rewrite this? Let me scoot it over in the middle. Suggestions. Could I make that look like a regular trinomial if I pick the packets carefully? What would the packets have to be to make that look like a regular quadratic trinomial? Like, could I make it, my question is, could I make it look like the coefficients here are 1, negative 1, and negative 12, right? Right? Those are coefficients in a trinomial we can deal with. Could I make it look like something squared, 1 times something squared, minus 1 times something to the 1, minus 12? Could I do that? Randy, could I do that? What would have to be in those parentheses? If I want to make this look like a Unit 4 trinomial, where I just get 1 times something squared minus 1 times that something minus 12, what is it? What could the something be? What would it be? Well, this first term is going to still have to equal whatever that is. It's going to have to equal the same thing, but I just have to write it in a way that makes it look like something squared. What squared is x to the fourth? Say it again. X squared, that's it. Yeah, you're right. X squared, right? Everybody see that? So it would just have to be, I could think of this as being x squared squared is the same as x to the fourth. Well, there's an x squared. Okay, so it works in pieces of x squared, doesn't it? Right? And so now if I were going to factor this thing, Abby, what's going to have to go there and there? X squared, yeah. Because when I distribute, I've got to end up getting x squared squared, which is the same as x to the fourth, right? So these would have to be x squareds. Now, what would the magic numbers have to multiply to here? Trenton, what do the magic numbers have to multiply to in this trinomial? Negative 12 and add 2. So what would those be? Okay, everybody buy that? Negative 4 and 3. Okay, good. So it factors. That's how we would have factored that one in Unit 4. Okay, now though, can we go further? What could we do? Johnny, you see something? Ah, yeah, there we go. Good. Look, we could split this guy apart. This is x squared minus 4. We could break that up using a difference of squares because 4 is the same as 2 squared, right? And we get what? And x minus 2. Excellent. And then over here, we've still got this other factor that we can't go further with because that's a sum of squares pattern, and we can never factor those, right? Plus 3 is not a square. So that would be my answer. Okay, give me 1 to 5 so far. Is that making sense? Okay, good, good. Man, you guys just get this stuff. Okay, what about this one? Yikes. What could I do there? Take a look at that one and see, is there a way, and kind of just think about it on your own. You can talk to your neighbor about it a little bit. Is there a way that I could make that look like a quadratic trinomial instead of a 6-degree polynomial? Tuessa, you got an idea? Okay, yeah, if I broke this into pieces of x cubed, it would work, wouldn't it? Right? I could write this as x to the 6th is just x cubed squared minus 5 times x cubed minus 24. So in pieces of x cubed, it looks like a regular old quadratic trinomial. Something squared, or something squared minus 5 something minus 24. That's a unit 4 problem, right? What would the magic numbers be here? What do you think, Malin? What do they have to multiply to, the magic numbers? Yeah. Just the magic numbers. So here's like this. Imagine those are just x's instead of x cubes. If I had x squared minus 5x minus 24, what are the? Let's start with the x values. I think that's what you're expecting. So if I were going to factor this thing now, what has to go there and there? When I distribute, I've got to get x cubed squared. So what do you think? What would have, Malin, what has to go there and there? What if I factored this? What if I had, let's try something different. What if I had y squared minus 8y plus, no, not plus, let's do minus 20. If I factor this, what has to go there and there? What has to go there and there if I factor that? I mean, you did this 1,000 times. It's got to be y, right? So now what we got to get magic numbers that go there and there. What do they have to multiply to? Just like from unit 4. Say it again. Negative 20, okay, and add to negative 8, okay. So what would those be, everybody? Well, multiplies to negative 20 and adds to negative 8. Yeah, negative 10 and 2. There you go. So negative 10 and positive 2. Okay, so up here it's the same thing. It looks more complicated, but remember, everything in the parentheses just counts as one thing, right? Okay, so then what's going to have to go there and there? Arson, what's that going to be? Good. Those have to be x cubes, because when I distribute, I've got to get x cubed times x cubed, which is x cubed squared, x to the 6th. Okay, and you guys already told me the magic, well, actually, this is a different one. What would the magic numbers be here? Negative 8 and 3. Okay, good. So we get minus 8 plus 3. Good, we factored it. X cubed minus 8 times x cubed plus 3. In unit 4, we would be done. But are we done here? Got an idea, Tuesse? You're pointing at this one, I can see. What's going on with this one? Ah, okay. What pattern is that going to follow? Yeah, because 8 is the same as 2 cubed. That looks like difference of cubes, doesn't it? So if we replace the 8 with a 2 cubed, okay, this guy is going to factor, right? So then this is good practice. What's going to be the linear factor that we get from x cubed minus 2 cubed? X minus 2. What's going to be the quadratic factor that we get? Whoops. What's the quadratic factor going to be? X squared, right? X squared. Okay, good. Plus 2x. Plus what? You guys should know this. Plus 4, plus 2 squared, right? And then we've got this other factor out here, x cubed plus 3, that we can't do anything with. So this would be our answer, right? Okay? Make sense? Okay. All right, board work. Try that. Go to the boards and try that. Okay, last one. Last one. Take a look at this guy. So what would we do here? Yeah, what are we going to do there? That's a little bit tougher, right? Slip and slide. Good, but we're going to do slip and slide with packets of what? Meaning by 3, you mean x cubed, right? That's the exponent you're talking about. We're going to split this into, we're going to think about this. Even if you don't write it this way, you're going to think about this as 3 times what squared? X cubed. Plus 5 times what? X cubed. So it's in packets of x cubed, right, Trenton? Quit researching math on your phone. Put that away. And so we're going to do slip and slide the way we normally would now, right? Okay, so we'll do a little side work over here. We're going to slip the 3 over and multiply by the negative 12. So that gives us x cubed squared plus 5x squared minus 36. Now, can we factor this? These would have to be x cubes, wouldn't they? Right? Because when I distribute, I've got to get x cubed squared, x to the 6th. What magic numbers multiply to negative 36 and add to 5? Which ones are they again? Okay, positive 9 and minus 4. Okay, and so that looks pretty good, right? What's the last step? That worked out. What's the last step of slip and slide? Divide the magic numbers, 9 and negative 4, by what? By 3, whatever the number was that we slipped. Okay, and then when I simplify those, I get x cubed plus 9 over 3 just becomes a 3. What do I do with the 3 over here? Because that fraction won't reduce. Yeah, I'm going to slide it up in front of the x, so I'm going to get a 3x cubed minus 4. And that is my answer. Right, so it's regular slip and slide, only difference being instead of writing down x each time, we're writing down x cubed. Okay. And that's honestly like that's kind of like the challenge problem is going to be one like this. But the other ones are all, in reality, if I were solving an equation like that, I would probably be using the quadratic formula anyway, right? Okay. So go to it. Assignment is, I'll make it live right now and then go to it.